You're tuned in to Iri-e-learning, and I'm your host, Teacher. This is our second segment on Lesson 1B, where we examine the evidence of osmosis.
Check the description box for the links to all the videos associated with this unit.
By the end of this lesson, we should be able to observe the changes that occur during osmosis, explain the process of osmosis in plant cells, and write an observation and discussion. It's experiment time, and for this experiment, we're going to observe the process of osmosis in potato chips. So the materials required: 1/4 cup sugar, which is sucrose, 3/4 cups water, a transparent glass container, a spoon for mixing, 2 Irish potato strips or chips. Now it's time for the experiment procedure. We're going to take a look at that. But before we do so, let us make note that it's important to cut 2 potato chips of equal dimensions from the Irish potato. If you're going to try this experiment, do not use prepackaged fries, because sometimes they are processed, which interferes with the expected results. Now, when you're preparing a concentrated sucrose solution, add as much sucrose to the water until no more sugar can dissolve. So you might see some residual sugar crystals. Then decant the concentrated solution into the container you're going to be using in your experiment.
Step 1 for the procedure: pour the concentrated solution into the experimental glass container. Step 2, place 2 potato chips of equal dimensions into the sucrose solution.
Now, once we have set up our experiment, it's time for observations. And here are a few questions that we can use to guide us as to some important things we need to look for. 1, to describe the feel and flexibility of the potato chips before placing them in the concentrated sucrose solution. Where did the potato chips settle after being placed in the sucrose solution? During the experiment, were there any notable changes in the appearance and position of the potato chips in the sucrose solution? And for us to give some details surrounding the changes that occurred. And 4, to describe the feel and flexibility of the potato chips at the end of the experiment, so we can actually have some comparison with what was at the beginning and what happened towards the end of the experiment. So here we go. It's time for observations. Make sure to pause the video if you have to. Take note of its feel and flexibility. Note where the potato chips were. What is happening to the potato chips now? Once again, where are potato chips? Wow, what is happening here? Were we able to do that at the start? After making our observations, we can now go ahead and do our write-up.
Here is a sample observation report. At the start of the experiment, the potato chips were turgid, that is firm and inflexible. When placed into the concentrated solution, the potato chips floated on the surface of the solution. Within 50 minutes, the chips began to descend or sink within the concentrated solution. At 120 minutes, the chip had sunken entirely and assumed the curvature at the bottom of the container. The chips also had a shrunken and soggy appearance. The potato chips were very flexible and flaccid, that is soft and limp, and were easily bent and twisted in all directions without breaking. Please keep in mind, you should only use this report as a guide for writing your own observation report.
The observation, of course, is followed by the analysis and interpretation, which is also called the discussion. And this is where we explain our results along with any significant steps taken in the procedure. So here we have a diagram that illustrates the process that took place in the experiment. The diagram shows our potato chips bounded by the dotted lines here immersed into the concentrated sucrose solution. So if we take a look at our key at the top left of our screen, we'll see that the blue dot represents water molecules while the brown dot represents sucrose molecules. And please note they are representations and not the actual color of the molecules. Now, from our diagram, we can immediately see that the potato chip consists of a greater quantity of water molecules compared to what is in the sucrose solution directly surrounding it. And so as a result, we can make note that the area of higher water molecule concentration occurs inside the potato chip, and the area of lower water molecule concentration occurs within the sucrose solution. So as mentioned before, when there's a difference in the concentration between the two areas, this generates a concentration gradient. And as a result, the water molecules leave the potato cells, which is a region of higher water molecule concentration, but first passing through the cell membrane. And as we know, the cell membrane is a semi-permeable membrane. So therefore, the movement of water molecules through the semi-permeable membrane from an area of high to low water concentration is osmosis. Now that we have a better understanding of what happened during the experiment, we can review these 7 questions, which we can use as a guide when writing a discussion. So first, explain the feel and flexibility of the potato chips at the start of the experiment. What were the regions of high and low water concentration? What functioned as a semi-permeable membrane in the experiment? State the net movement of water molecules in the experiment. Explain the changes in the feel and flexibility of the potato chips at the end of the experiment. Name the process that occurred during the experiment and provide a definition. And finally, why did the chips float when placed in the sucrose solution and then sank after some time? So once we have the answers for these questions, we are on our way to writing an excellent discussion.
Here is a sample discussion. At the start of the experiment, the potato chips were turgid, indicating that the cells were fluid-filled with water, which pushed against the cell walls. The turgidity is also the reason for the inflexibility of the potato chips at the start of the experiment. The chips floated in the sucrose solution because the water in the potato cells was less dense than the concentrated sucrose solution. There were specific conditions in the experiment that prompted the movement of water. These included the areas of higher water molecule concentration within the cells of the potato chips and lower water molecule concentration within the sucrose solution. The notable difference in the water molecule concentration between these two areas established a concentration gradient. The concentration gradient then initiated the movement of water molecules from the area of higher water molecule concentration, that is within the potato cells, through the semi-permeable membrane, which is the cell membrane, and into the area of lower water molecule concentration, which is the sucrose solution. This net movement of water molecules through the semi-permeable membrane from the area of higher to lower water molecule concentration is called osmosis. The potato cells became plasmalized as the water molecules left the cells, which caused the chips to become flaccid and shriveled. This increased the flexibility of the chips, allowing them to be bent and twisted without breaking at the end of the investigation. Keep in mind, you are to use this sample discussion report only as a guide when writing your lab report. Let us summarize the lesson points. Pure water is less dense than concentrated sucrose solution. The cell membrane of plant cells is a semi-permeable membrane. A concentration gradient develops when there is a difference in the water molecule concentration on either side of the cell membrane. Osmosis in plant cells involves the movement of water molecules through the cell membrane from an area with a higher concentration to an area with a lower concentration.
We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.